Hi everyone. Last class we have discussed about torque equation and we have derived the torque equation of DC motors. Today we are going to discuss about types of DC motors. The types of DC motors is classified based on the excitation of field winding. So DC motors can be classified into separately excited and self-excited, right? For exam point of view, let us concentrate on self-excited, that is series motors, shunt motors and compound motors. What is series motors? In series motors, what happens? The field winding is connected in series with armature, that is the field winding is connected in series with armature, right? In series motors, what happens? This turns, the series field winding turns are thick. Since it is thick, it has low resistance. Okay, since we are supplying the voltage, the current which flows across the series field and the armature will be same. That is what? Same current flows through the field winding and armature. So we get IA is equals to IL. By applying KVL, we get the equation V minus IL RSC minus brush drop and the armature drop, that is IA into RA is equals to induced EMF. Let us go to the shunt motor. In shunt motors, what happens? The field winding is connected in parallel with armature. That is, the field winding, that is RSH, is connected in parallel with the armature. And the turns of the field winding will be thin. Okay, so since the armature current is flowing IA, we are supplying the voltage V from your DC supply. The DC current IL flows and gets divided through field winding, that is ISH, and another IA, that is armature, which flows through armature. We get it as IL is equals to IA plus ISH, and where we can form the equation IA is equals to IL minus ISH. By applying KVL, we get it as V minus IA RA minus brush drop is equals to induced EMF. The voltage drop across the shunt field is given by ISH is equals to V by RSH. Let us go for compound motor. In the compound motor, we have both series field as well as shunt field. That is why it is called as compound motor. So compound motor can be classified into differential compound motors and cumulatively compound motor. That is cumulatively compound motor. What happens in differential compound motors? In differential compound motors, the series field and the shunt field are connected in such a way that the flux produced by them are oppose each other. Okay, the flux produced by the series field and the shunt field oppose each other in differentially compounded motor. So that what happens, the total flux we get that comes out from the pole decreases, hence the flux decreases. So when the flux decreases, we have speed is inversely proportional to flux, hence the flux decreases and the speed increases. Coming to cumulatively compound motor. In this type of motors, the series field and shunt field are connected in such a way that the resultant flux, the flux that is from the series field and the shunt field had, so that the flux come out from the pole, increases. That's how, since we know that speed is inversely proportional to flux, as the flux increases, the speed decreases. Hence, these cumulative compound motors are used where the speed required is less. For the application where the speed required is less, whereas differential compound motors where the speed requirement is more, there we use the differential compound series motor. Right? I hope you understand this video. If you have any doubts, please comment below.